Yeah, so before we actually do this problem, we need to make sure we draw a rectangle and see what's going on here. The length is increasing at a rate of 3 feet per minute, so the length is getting bigger, but I don't know how we're going to write this. Yeah, so let's do that. I have an idea. So the length is getting bigger, but the width is getting smaller. Okay, so it's kind of a weird problem, and when this would ever happen, I don't know. I don't really care, but it's a good way to practice your want, know, relate. It's a good way to practice your related rate problems. So let's see here, length. Let's let this be the length, and let's let this be the width. It says the length is increasing, so this is important though, because we know that the dl dt, it's increasing at a certain rate, and that's 3, but the width is decreasing at a rate of 2 feet per minute. So the width, dw dt, the width is changing at a rate of -2. And if you got this problem wrong, it's probably because you forgot to put the negative. We know that any quantity whose rate is getting, whose number is getting smaller, its rate of change is negative. Okay, so then when the length is 50 and the width is 20, what's the area? Is the area increasing or decreasing, and at what rate? So we would need to know what's the rate of change of the area at the precise moment when the length is 50 and the width is 20. And is the area increasing or decreasing? Well, we know that the area of a rectangle is just the length times the width. The other place where students make the most mistakes is in this spot right here, dw or dA dt. So when you take the derivative of the left, you get dA dt, and that's exactly what we want anyway. We want our dA dt. Okay, but if you notice on the right hand side, we have the derivative of a product, and the derivative of a product would be not the product of the derivatives. It's the first times the derivative of the second plus the second times the derivative of the first. Okay, and then so we can let's put our work right up here, and so that's our dA dt, and that's exactly what we want. But we want the dA dt at the precise moment when the L is 50 and the W width is 20. They're all in feet, right? Feet per minute, feet per minute, feet and feet. Okay, just got to make sure. Sometimes you get rates that are different and you have to convert. But the dA dt at this precise moment would be we would just need to go ahead and substitute. Notice that we've got an L right down here, and so we're going to substitute the 50 for the L. Oops, put that in purple. 50 for the L, and then we have a dw dt. Well, the dw dt was given to us. That's -2. Okay, and then plus we have our w, and the w at the precise moment we want our dA dt. The w is 20, and then we need to put in our dl dt, and the dl dt is 3. So we have -100 plus 60, and that's equal to -40. And the dA dt, that's the area, the rate of change of the area, that would be in square feet per minute. Okay, so always have to double check, make sure you're getting the units of measure in the right place. Okay, so that's an answer, but let's make sure we're answering the question. When the length is the area increasing or decreasing? So the answer is actually decreasing because of the negative number there, the rate at which the area is changing. Therefore, we say the area is decreasing. Okay, decreasing at a rate of 40 square feet per minute. And that is actually our answer. Okay, and so we can might as well put a box around that as well. So we got our rate, And we interpreted what that rate actually means by writing a sentence that answers the question. Okay, so that's full credit right there.